and that would probably help if I unmuted the mic. But I'm gonna go ahead and make sure everything is set up properly, check the levels. That looks good. See my inception a little bit. So I'm on vacation this week, and I am kind of stuck at home like the rest of you because of the pandemic that is going on around us. So I thought it would be a good idea to spend some time playing around with some new to me techniques for attacking applications. There's a couple things that have been on my list for a long time to learn more about. One of them is request smuggling, and the other is deserialization attacks, specifically in Java, .NET, and PHP. I think Ruby also has plenty of them, as well as Python. But today it seemed like a reasonable plan to tackle some of the request smuggling stuff. I don't know how far we'll get. I've got maybe about an hour and a half to play right now with this, but we can come back on later tonight or maybe more this week. I know very little about this attack. Effectively, the way that I think it works is it depends on chunked encoding, which is a way to send a server to send data back to a client, where the server will not know the size of the response at the time of sending the headers. So typically when a server sends a response, you have some HTTP headers, and it's going to have status code, it's going to have some information about your encoding, and just some other stuff that the browser might need to figure out what to do with the response coming in. And one of those fields is a content length header, which will tell the client how much data to expect. And typically what will happen is the client will read that many bytes of data and stop after that. Sometimes you will not know, as the server, will not know the size of the response at the time of sending the headers. And once you've sent the headers, you can't just go back and modify them and say, oh yeah, I changed my mind. The content length headers is actually, the content length of this response is actually going to be 500 bytes rather than 400. So I needed to keep reading after that initial 400 that I sent you another 100 bytes so you can get it all. So it'll use what's called chunked encoding. And chunked encoding is a way for the server to send pieces of data just continuously until there's some sentinel that lets the client know okay, the server has finished sending all the data. I can stop reading from this response now. I don't have any more data to read. And so what I think it does, and we'll figure out if this is actually true. But what I think it does is you craft a request or a response to confuse the server, to make it think that the response or the request has the request has finished, even though there's more data there. And then you can add a second request, and when someone else comes along and makes that, sorry, I just confused everyone by talking about responses. But you can also do this with requests as well, and that's probably what this actually is going to be. So you craft your request in such a way that you make the server think it's reached the end of the request, but then you send some more data, and that data just kind of sits there in its buffer. And there's an optimization where you can reuse sockets, and so you might still have data there. And so if someone else comes along, they open a connection, they start sending data, and there's this extra request that's sitting in that buffer. And when it starts going, it's going to service that request and and deal with it. So that's my shot in the dark of how this might work. I know that Portswigger has has published a bunch of stuff about this. We might start looking there. I've also just installed Burp Suite on here because I don't have many tools installed on this machine. Let's see, Portswigger request smuggling. So I think this is their blog post or something that kind of talks about how it works. We can, I guess we can read together through this, see how close I was or how just absolutely wrong I am, and then we'll see if we can get together some kind of example where this type of vulnerability exists, and then try to exploit it. I'm assuming that there's like Docker containers that are already like pre-set up for this, and maybe we can just grab one of those and spin it up and run it. If not, maybe we'll have to like actually craft one. I think that the way you do it is by having like a misconfigured reverse proxy, and it might have been that like reverse proxies in their default configuration were vulnerable to it, and so it's just a matter of switching out of what the current default configuration is back to the old vulnerable version, and then putting like a web server like behind it to reverse proxy to, that does something. All right, so let's go ahead and just read through this. I guess I can read aloud. In this section, we'll explain HTTP request smuggling attacks, describe how common request smuggling vulnerabilities can arise. Cool. HTTP request smuggling is a technique for interfering with the way a website processes sequences of HTTP requests that are received from one or more users. Request smuggling vulnerabilities are often critical in nature, allowing an attacker to bypass security controls, gain unauthorized access to sensitive data, and directly compromise other applications. So we've got this little diagram here. Now let's go ahead and increase the size. If I can figure out how on this keyboard to do that. I think it's like, maybe like that. Yeah, there we go. So you send a post request, and so like this is what I was talking about where we're making this request. I think the 0 here is the chunked encoding like sentinel, so it knows you've hit the end of the request. So we make a post request, and then in our body, we're basically, or I guess this is not even the body, this is like the end of the, this is like still in the headers because we haven't had a carriage return new line here. 1 second. All right, let's jump back into this. So I think the 0 here is the sentinel that it uses to figure out when it hits the end of the request. But we don't have the carriage return new line here, and so it's like stuck in the headers. It could be that this is like abbreviated, but I guess we'll get to that in a second. And so front end server, this is like I think this is our reverse proxy. It sees this as one request, but the backend server sees this as 2 requests. And so it's a desynchronization between the reverse proxy and the server behind it. And so what was originally 1 request here is now treated as 2, and so it's going to do some magic. So what happens in an HTTP request smuggling attack? Today's web applications frequently employ chains of HTTP servers between users and ultimate application logic. Users send requests to a front-end server, sometimes called a load balancer or reverse proxy, like we talked about, and this server forwards requests to one or more back-end servers. So yeah, so we have a reverse proxy that does our round robin load balancing, or load balancing based on geolocation or whatever, or failover, and it reverse proxies to our application server. This type of architecture is increasingly common and in some cases unavoidable in modern cloud-based applications. When the front-end server forwards HTTP requests to a back-end server, it typically sends several requests over the same back-end network connection because this is much more efficient and performant. Okay, so this is, I think, where it starts to deviate from what I had originally talked about, which was like reusing the same socket. It sort of is using the same socket, but it seems like it's doing like pipelining requests that are unrelated, and it's not just like a strictly like a socket reuse kind of situation. I don't know if it's possible to do the socket reuse situation. It might be, but it would depend on the server, and I guess we'll get to that a little bit later. The protocol is very simple. HTTP requests are sent one after another, and the receiving server parses the HTTP request headers to determine where one request ends and the next one begins. Like we said, so these are two clients. They're both hitting the same reverse proxy. The reverse proxy is forwarding both requests to the backend server, and it looks like there might be two different servers here that it's load balancing between. In this situation, it's crucial that the front end and back end systems agree about the boundaries between requests. And this is kind of getting to that point where I said you have that sentinel for trunked encoding. Otherwise, an attacker might be able to send an ambiguous request that gets interpreted differently by the front end and back end systems. So we see here the attacker sending it. The front end thinks that this is one request, but it's sending two effectively requests right here. And this real user sends a request. And the front end is sending what are now these two requests, and the back end the one behind it, now there's three in this pipeline going to the application servers. So this first one gets routed to this backend server, and the second one gets routed to this one, and then the users goes to here as well. And so I don't know if these are treated as two or one here, but effectively this user never gets their response back. They get the response for this like malicious request. So you're forcing the server to handle it like for that user. Here the attacker causes part of their front end request to be interpreted by the back end server as the start of the next request. This is effectively prepended to the next request, so it can interfere with the way the application processes the request. This is a request smuggling attack, and it can have devastating results. And we'll see why, I assume, shortly. Most HTTP request smuggling vulnerabilities arise because HTTP specification provides two different ways to specify where a request ends: the content length header and the transfer encoding header. Back to the chunked encoding that I was discussing earlier. The content length header is straightforward. It specifies the length of the message body in bytes. For example, it has an 11 byte length, and it has 11 bytes here. The transfer encoding header can be used to specify the message body that the message body uses chunked encoding. This means that the message body contains one or more chunks of data. Each chunk consists of the chunk size in bytes, expressed in hexadecimal, followed by a new line, followed by the chunked contents. The message is terminated with a chunk size of 0, which is the 0 we saw. So it is a sentinel, but it's not just magically 0, it's 0 because it thinks that there's 0 bytes left. So it's like a 0 byte chunk. Many security testers are unaware that chunked encoding can be used in HTTP requests for two reasons. Burp Suite automatically unpacks chunked encoding to make messages easier to edit and view. Browsers do not normally use chunked encoding in requests, and it is normally seen only in server responses. I don't know that that's true. So yes, in requests that is true. It is very common in server responses, but I have definitely seen it on the client side. When I worked at a previous company, we built a lot of middleware that had to do all kinds of crazy stuff. And oh my god, was it difficult to basically buffer a whole request that you had no idea what it was going to look like yet. and then keep it treated exactly the same and put it back on the not on the wire but in memory, so that you're not like taking a chunked request and making it unchunked. It was very difficult and so painful. Since the HTTP specification provides two different methods for specifying length of HTTP messages, it is possible for a single message to use both methods at once. Wait, so it's possible for a single message to use both methods at once, such that they conflict with each other. The HTTP specification attempts to prevent this problem by stating that if both content length and transfer encoding headers are present, then the content length header should be ignored. This might be sufficient to avoid ambiguity when only a single server is in play, but not when two or more servers are chained together. In this situation, problems can arise for two reasons. Some servers do not support the transfer encoding header in requests. Some servers that do support transfer encoding header can be induced not to process it if the header is obfuscated in some way. So I think this has to do with how you end up like changing the headers, like you change the casing of it or something, and it's just confused. If the front end and back end servers behave differently in relation to the possibly obfuscated transfer encoding header, then they might disagree about the boundaries between successive requests, leading to a request smuggling vulnerability. So how do you perform it? Request smuggling attacks involve placing both the content length header and the transfer encoding header into a single HTTP request and manipulating these so that the front end and back end servers process the request differently. The exact way this is done depends on the behavior of the two servers. I don't know what the CLT is here. Oh, content length, transfer encoding. Depends on the behavior. So I guess this means like the ordering you do it in. So if it's content length and then transfer encoding, the front end server uses content length and the back end uses transfer encoding. And this is opposite. So the front end uses transfer encoding and the back end uses content length. And then in the last option here, the front end and back end both support transfer encoding header. But one of the servers can be induced not to process it by obfuscating the header. Oh, okay, so this is whether or not it's supported. So, okay. Here, the front end server uses the content length header, and the back end server uses transfer encoding. So, front end content length, back end transfer encoding. We can perform a simple HTTP request smuggling attack as follows. So we're posting to /. We have a content length of 13 and a transfer encoding of chunked. So it looks like this would be our first byte. So let's go backwards here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10, 11 for the character turn new line and 12, 13 for the character turn new line here. That would be my assumption. So the front end server processes the content length header and determines that the request body is 13 bytes long. Up to the end of smuggled, this request is forwarded to the backend server. The backend server processes the transfer encoding header so that it treats the message body as using chunked encoding. It processes the first chunk, which is stated to be 0 length, and so is treated as terminating the request. Okay, so 0 length terminates the request, and then moves on to the next one that we've added in here. And so we probably want to change smuggled to be like another request, like get here or post here or something like that. The backend server processes the transfer encoding header and treats the okay. HTTP request smuggling basic CE vulnerability. Oh. Wait, do I gotta do this? Hold up, let's open this in a new tab. Front end backend server. The front end server doesn't support chunked encoding. The front end server rejects requests that aren't using. do this in Burp or do I do it at the website? The fuck is this? This is the lab, okay. So, lab description. The lab involves a front end and back end web server. The front end doesn't support chunked encoding. The front end server rejects the requests that aren't using get or post method. The front end rejects requests that aren't using get or post. To solve the lab, smuggle a request to the backend server so that the next request processed by the backend server appears to use the gpost method. Okay. Let's open Burp. I've never used this on Windows before. Give me 1 second. We're gonna have to do something real quick and not log in to here on stream. Let's see my license key. Sorry everyone, I'm not gonna give out my license today to everyone. Do a temporary project, Burp defaults. All right, I think we're good to go. Let's move back to desktop. Nope, we are not good to go. I still have this one screen. Go back to webcam. And there. All right. There we go. We'll minimize this. All right, so we have Burp open. And we need the browser here. Intercept is off. Let's do some. I can remove these, right? Yeah. Can I just clear these? Yeah, just like clear all this shit. We're gonna go back to here. Yeah. This is the host that we're gonna add into here. Yes. That is the move. So now I should be able to go to here and we'll see stuff pop up in here. All right. I think I want to use this. Maybe. All right. So we're gonna make so gposts. Don't need a cookie. We might need a host header though. then we're going to do transfer encoding chunked. All right. We're going to do a 0 length chunk. And so this ends up being what, 1. There's a way to turn invisibles on, aren't there? That's like a big new feature in this. I don't know. So we'll call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I think this works. We probably could have used like sequencer or yeah, this is it. This is what I wanted to use as repeater, I think. Because I don't actually care about any of that. Okay. Is it? Maybe? Target it. Yeah, just copy that. All right. So we got that done. And then I think we basically just need to hit this. Which it didn't work. So let's see here. We can go to our history, which is here, I think. One of these is it. We gotta find... Do repeaters things not go in there? I thought they did. It is gpost you want to hit, right? So it's let's go reread this real quick and refresh this to make sure that yeah, it's not solved. Okay. So the front end server and the back end server does not so the front end and back end server. Front end does not support chunked encoding. The front end server rejects requests that aren't using the get or post method. To solve the lab, smuggle a request to the backend server so that the next request processed by the backend server appears to use the method gpost. Manually fixing length fields in request smuggling attacks may be tricky. Use our request smuggling extension. I mean, we can do that. I wonder if my numbers are off though. So it would be 1, 2, 3. Can we do it? That's easier. Okay. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I must have miscounted. And then, do I need to actually hit it? Let's install the extension and see what it's using. Request smuggler. Where is the request smuggler. What was it called? It's HTTP request smuggler. This. All right. I don't know what the smuggle probe does, but it doesn't seem like it's doing anything. Either way, we should be able to disavow it. So I did. Why is it 21 there? So it's 1, 2, 3. Can I just get the number of bytes here? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21. My math. Apparently I just can't count. Is it 20? That's interesting. Like, do I need to hit a specific, I wonder if it's an intruder or something. Like where is this probe thing? Like, why? Manual collab domain here. I don't care about that. Yeah, I don't know where. Okay, so yeah, it found. I did uppercase here. I wonder if it has to be lowercase. Okay. Getting closer. So if I do this again, we'll send this. And then I go here, it's gonna give me invalid. Okay. So we are starting to smuggle, but something's wrong. Maybe our size is off or something. I think we're in a known good state now. So let's count this again, make sure we have the numbers right. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it should be 21 or 23. Because you need the character to turn a new line. So let's do 23. So that's not what I wanted. So it keeps changing this automatically for me. That looks fine. Maybe the cookie is needed. I don't know if we need that, but we can try it. Invalid head request. That's not right, but oh, alright, yeah, there's extra stuff here. Invalid request. I don't know why there's an invalid request, but there's an invalid request. I wonder how we can figure out what is there. What's there? Network. That's interesting. It's interesting that it didn't go as a failure here. It did there, okay. We don't know what it thinks our let me try putting this cookie in there just because it's the one that we're using. I don't wonder if I have to use like 1.1 rather than 1.0. Okay. So we probably don't need the cookie. It doesn't seem to be affecting it. It's possible that our size is off. I wonder if it says it doesn't support this, so maybe if we do this first, it won't matter. So that works, but that doesn't work. So because it doesn't support chunked encoding, it's probably going to ignore this header and use this one. Which is cool because the next one that does support chunked encoding will pick this and ignore, this one, hopefully. And it is 21 here. We can go back to here, possible request smuggling. It's like, I'm really feeling this. I wonder if it's... oh, that's interesting. So we can do this. That's interesting. So yeah, if we just do that, does it work? This will request the victim's request. Edit to achieve the desired effect. Do I not have to care about this? Oh, I wonder if I don't need that. And then it would be like post / gpost. No, so that's... Did that work? So it's not solved. Like this. So you can launch a smuggle probe. So it's interesting, you can do this from here. But I don't understand. Go over there again really quick. So the front end doesn't support chunked encoding, but it does support doesn't support, yeah, but it does support content length. So it would be content length. I don't know how this interface works, so like I don't know. This will prefix the victim's request, edit it to achieve the desired effect. But it seems like it doesn't handle the stuff for you here, does it? Like if I just get rid of this, and I make this G post. That's what I want. But none of... That's not solved, right? I'm still not understanding why this isn't working. Maybe we can move this around and is it... That doesn't work. It's so weird. Like I don't. It's launching this, but I don't know if it's launching the right script or not. There should be like a walkthrough how to use the tool. This is all the cool shit that we're gonna get to as soon as we can figure this part out. I don't know if we need to have a content type. Maybe like it wants more data or something. We can try adding stuff in. I don't know. It's possible. Yeah, so it's sitting there, but it's the wrong. Duplicate header names are not allowed. So I don't know if it's getting confused then. It might not be desynced. So I think it's seeing the same host header. I don't know. It might be messing with the content length header. Like this is definitely getting updated based on this, and I don't know if it's the right value. It's definitely possible that it's wrong. I don't know how to turn that off. There's probably an option to make it not do that. But it looks like it's not actually like figuring out that these are two different requests. Because when I had this here, it looked at the front end server. Or maybe this is the back end server. The back end server doesn't think this is the second request. I think this is all one request. We can swap this back to again and see if that makes a difference. But I don't know that it will. Unrecognized method gpost. Okay. So that's oh, I solved it. Can I unsolve it to see which one worked? Oh shit. Well, let's see if we can. Let's see what their solution was. So. Oh, that's interesting. So that's kind of cool that you can do it like just this. This actually should go back here then. So it looks like they can do this way. So it looks like this should work. Yeah, and I guess the reason this works is because the G is left there, and the next post request comes in. We could do this, and then my next one should be like get if I make a get request to it. Yeah. So that's pretty cool. I still have no idea how to use the tool, but we can do it by hand, which is nice. So we did that. These labs are pretty sweet. Like I didn't know that this was even offered. All right. So finish that. Refresh there. So we solved that. So this was the content length transfer encoding vulnerabilities. Now we can do the transfer encoding content length ones. So here the front end server uses transfer encoding header, and the back end uses the content length header. We can perform a simple HTTP request smuggling attack as follows. Content length is 3, which is the 8 here, which is the length of this, followed by your character to your new line, that's our 3, and then this chunk ends up being what, 1, 2, 3, 4, 5, 6, 7, 8, and there's no character to new line here because it's just 8 bytes, and then we have an empty one right there. To send this request using burp repeater, you first need to get the repeater menu and ensure that update content length option is unchecked. Okay, so that is something we need to do. I don't know where that option is. We're in repeater. So presumably there's an option here. Go to the repeater menu and ensure that update content length option is unchecked. That's not what I wanted. I don't know where this menu is, but repeater. There. That's what I wanted. Alright. Yeah, cool. Thank you very much, XP Command Shell. As you can tell, I'm not super like I know burp like enough for the basics, but like beyond like the basics, I'm kind of a noob with it. I also really want to get better with it because like there's so much cool shit you can do that I just like I don't know, and I kind of want to find a class that just like goes into like how to use burp really well. Like I don't want like an intro to web hacking class because like I would consider myself pretty proficient already, and I know like a lot of the web vulnerabilities, how to exploit them. I just don't know how to use burp really well, and so I don't want to sit there like learning like this is what XSS is, and this is what SQL injection is, and this is how you exploit them. I just want like a crash course in like this is how you get really good with burp. All right, so let's do this next lab here. So the front end does transfer encoding, the back end does content length. Cool, so we're going to access the lab. I'm not like taking a break. Oh, I'm doing not work, which is the same as my work. So this lab involves front and back end, blah, blah, blah. To solve this lab, smuggle a request to the backend server so that the next request processed by the backend server appears to use the gpost method. Okay. We access the lab. This is the host. Maybe it's the same one for us. Maybe it's not. I don't know. It doesn't look like it is. Well, yeah, it's totally not the same. These are probably like Docker or like hosts or something. All right. So let me change this. Drop that in there. Okay. So let's see here. We want it to be gpost, our transferring, where the back end does, the front end does transfer encoding, so we can do chunked. And the back end is there. So be what, like 3? One, two. So this becomes 1, 2, 3, 4. Alright, I kind of think that might be it. Oh, you know what? I need to add this into the scope. Yeah. That's not helpful. Repeater. And I clearly fucked that up. One, two, three, 4. So it's 1, 2, 3. Oh shit. This is, I think, our burp Chrome. It looks like you can do it the other order. So I wonder if we can do this or not. Where this goes first. So the front end is gonna read it chunked. So the front end processes the transfer encoding header, so it treats the message body as using chunked. Okay. So yeah, it is gonna be 3 still, because we're gonna basically, and this will be 1. So the front end is gonna do transfer encoding chunked, and it's gonna read one, two, three. So it's timing out, probably because it's trying to read more data than we have that we're sending. So, man, this is confusing. Like, I'm sure it gets much easier, like, once you've done this a bunch, but, like, I'm a dummy, and it's confusing until I get to that point. Um, so the front end's gonna read our chunked encoding. Uh, and shit. So I kind of think I need. So I don't know if I need a new line here. I guess I do. So like it's gonna be. So it's gonna be 1. And then this is the one that needs to get updated. So it's gonna be uh, 3. Invalid request. So why is it not working? I wonder if it needs to be before the content length. Doesn't seem to make a difference. Yeah, so our content length that our back end is going to read is 1, because we want it to just read the G, and we don't want it to read like any of this bullshit. But we need the chunked encoding to go, and it's going to read, so it's going to be 3 bytes, so 1, 2, 3, and then a empty. So I don't know why. And we want it to be gpost. Appears to use the method gpost. Yeah, at one point we'll figure out how to use this extension that like is supposed to make this easy. It seems harder than trying to figure this out, but I don't know whether that's true or not. I wonder if this isn't needed. Number 1, I wonder if it's doing anything bad. Okay, so taking away the 0 means that it keeps waiting. So that is there. And this also means it'll yeah, so I mean this is definitely right. But I wonder if there's 1 here. So that it only reads the G. Which is weird, like... Oh, I guess it's expecting to have a 0 there, and so it... Like, maybe you don't need that. Like, maybe I can just do that. Oh, that needs to be there. So we know that we want our content length to only be 1. I wonder what the invalid request is, though. Like, I mean, I can't imagine that we're gonna have to do this. It just doesn't seem necessary. So it's gonna read on the front end. Like, I kind of wonder if this needs to not be there. But I don't, it doesn't seem to work. Yeah, it says it's an invalid request. It doesn't seem to care. Yeah, it doesn't. Well, it's interesting that it needs to. Oh, so like 2 works though, which is strange. Why did 2 work? I wonder if it just doesn't care that it. So 3 is the correct value, but 2 should. I guess it's a number, and so it gets the first chunk, tries to read it, and there's data there, and then it stops. I'm so curious, like how the extension works. So there's a demo here. Well, let's watch this. Okay, so This looks nothing like the modern version of this. Okay, so this is where it's coming up to. So it so it seems like they. So, all right, let's go back here. Let's launch Smuggle Probe. I think we can get rid of this, and that's fine. Okay. I mean, I guess technically we just do this, and like that's it. Oh, 5 gateway timeout. Okay, so it's in the wrong host. Because yeah, it is confused. I think we found a bug in BERT maybe, where it didn't scan like the new host. Oh no, so yeah, we just haven't gone to the right host yet. So this is the new one. This should show up now. Yeah, so this should show up now in here. It does. We'll do a smuggle probe, and it's gonna find like new stuff, probably, hopefully. Come on. Do I need to do the G-post? I want to clear this, I think, but I don't know how to do it. I want all these to go away. I just don't care. Reset. Yeah. So yeah, I mean, we're hitting this host. It's not finding the Let's try this. I don't know why. Let me kill this. So I want to start from a good, like a fresh point. Invalid host. It's interesting. That host is good, I think. That host is still up, right? So why is it just timing out? Interesting. Okay. No history. Repeater's not doing anything. It's nothing's excluded or in like the scope. It's not blocking the scope. I mean, I can open. Yeah, I mean that seems correct. I wonder if it has to be post. No, it can't have to be post because we can hit it. It's just not. All right, let's open the browser. All right, we're gonna turn off that. Okay. We're gonna launch Smuggle Probe, and then presumably it should find the ability to do this. Maybe there's something about it being a transfer encoding content length one where it just doesn't do it. I kind of wish you could see like what was going on with the probing, but I don't. Nothing here. So maybe it wasn't broken before. It doesn't find it. Like, is there an option to set? Oh, interesting. I wonder if this is that G thing here. Okay. Still not sure why I can't do this, but we can send this to repeater. Don't need to care about any of this shit. So it's interesting that worked because it says that the front end server doesn't understand content length, but we don't have a transfer encoding in here. So like I don't know. Sorry, 1, and then this should be 3. This is back to where we were before. Yeah, it's invalid request. Not sure why we have an invalid request. Oh, I gotta turn this off. So, oh, that's interesting. We can make this G, which is hex, A, B, C, D, E, F. No, so G's not in there. So we know that's hex encoded. I wonder if we give it the value of G, like what's a G in hex? Capital G. It's 47. So like, I have a hard time believing this is gonna be like, okay, so we got like 47 bytes. 2, 3, 4, 5, 6. So that's 20, 40, 41, 42. Doesn't seem like it would work though, because that's not, I don't know if that's gonna get interpolated correctly. I wonder if, so we figured out it doesn't matter if it's there. But I did figure out that there's interesting. So this might be it. We might be able to just do this. I'm running through the labs for HTTP request smuggling on Portswigger's like blog. I don't know why it's using X's there. I'm not using X's as far as I'm aware. That's it. Oh. Yeah, so it'd be this. Yeah, these are all gonna fail. This will prefix the victim's request. So I wonder if this is the problem where I need to have a full request in here. I mean, it's still not working. It's still. Oh. 0 post. I think we might have solved it. It's not solved, but it's close. I wonder if the X should be there? Input request. That's so weird. I don't know. I think we're gonna have to wrap it up in a minute. Maybe I'll jump back on tomorrow or later tonight. We can play some more with it. But we're getting close. I don't quite understand like what it's doing, but anyway, yeah, we'll call it for here. Thanks for joining and helping out. I really appreciate it. XP Command Shell. The guidance on the burp stuff, I probably never would have seen some of that stuff. But yeah, have a good night, everyone.